Hi, I'm Jacob, and in this video I'll be teaching you how to use the state machine to create a boss fight in C# and Unity. A finite state machine is a way to organize multiple independent behaviors, and the reason we want to use a finite state machine is because if you look at any boss in a video game, you can break them down into individual movements or attacks or simple behaviors. In order to demonstrate this, let's break down the first boss from the game Cuphead, Blue.
A great slam and then stop.
Blue can be broken into three phases: small, big, and tombstone. While in small phase, Blue will jump at you and occasionally punch. When Blue gets to big phase, he will exhibit the same behavior, but his hurtbox and hitbox will be much bigger, meaning his jumps are more dangerous. In his third phase, Tombstone, Blue will slide left and right until they are above the player, in which they will slam down. Since Blue has three phases with two actions each, either a movement or attack option, we can diagram Blue as having 6 options in total, and each phase being gated by the amount of health remaining in Blue's health bar. If we were to display Blue's behaviors in a state machine, it would look like this. Now that we have an understanding as to why we want to use the state machine, let's talk about how to actually program it. So the first two things we're going to need are a script that is state. This just defines what state is so that our state machine knows what it is. It's going to act as a blueprint for all the states we make in the future. And then we're going to need a script that it handles actually changing from one state to another state. Okay, so when we go to write our state script, we're going to have 3 methods. We're going to enter, tick, and exit. There are also some keywords here we're going to want to look at. So we have at the top, we have public abstract class, and then the name, and then mono behavior. You're going to want to make sure that the keyword abstract is there. The reason being is abstract means the script will never be instantiated, or in other words, it'll never be put on an object in our scene in Unity. The reason we'd want this is because it is a blueprint, so we don't actually want it running in the scene. We want to inherit from it in our other state scripts. The other keyword here is going to be virtual, so you'll see public virtual void, and then you'll see one of the 3 methods. Virtual means it can be overwritten by scripts that are inheriting from this base script, which is something we want. We really just want to set up the basic logic here of enter, tick, exit, enter being the method that runs the frame we switch to the state, tick being the method that runs like update while we're in the current state, and then exit running once as we're leaving. Now let's take a look at making the state machine script. So at the top of the script, we do not have any defining keywords here. It's just going to be public class, and then state machine is the name, and then mono behavior. The variables we're using are going to be for storing state and also for checking if we are currently changing state. The boolean in transition is what's going to do that. In our start method, we are setting our first state. So this is going to be, here it's the decide state. It could be any state you want, just the first state you want to run to initiate everything is you're going to put in start, and you're going to say change state, and then brackets, the name of the state, the script name, and then parentheses and a semicolon. And then after that, we're going to have 3 methods. It's going to be change state, initiate new state, and call new state. Change state and initiate new state are both filters for call new state. Call new state is what is changing state and calling exit and enter. In our change state, we are receiving a state and we're checking to see if it's valid. So if this is a real state, then we'll pass that into our initiate new state. If not, we're going to print to console, try to change to a null state, and then return. Once we get to the initiate new state, all we're doing here is we're checking to see if it is the state we are currently in, and we're also checking to see if we're currently in transition. We wouldn't want to call transition if we are currently doing that already. If all that is okay, then we're going to pass that same state into call new state, and this is where we're going to actually change the states. So we're going to turn in transition to true, and then we're going to call the exit method, and then we're going to say the current state variable is equal to new state, which is the state we passed in the argument for call new state. And then once we do that, we're going to call the enter method of our new state, and then we're going to toggle the in transition boolean back to false. And then in our update, we're just checking for if we currently have a state, if current state is not null, and if we are not currently in transition, then take the current state and run the tick method in the update. And then just to clarify, the tick, exit, and enter we're calling here in StateMachine script is the same tick, exit, and enter we set up in the state script, which is why we wrote that first. And then when we make new states that inherit from our base state script, we are overriding those tick, exit, and enter methods, which are then being called by the StateMachine script. The way that we're going to want to write our individual states is at the very top, we're going to say public class, and then the name of the state, and then instead of mono behavior, we're actually going to change that for state. That's how we inherit the state script here. At the very top, we're going to want to make sure we have a protected StateMachine variable with whatever name you'd like. I use underscore StateMachine, and then in a awake method, we're going to say StateMachine equals getComponent StateMachine. This is just giving us a reference to the actual StateMachine script so that when we want to change state, we have a reference to it. Below that, we're going to say public override void enter, and then we're going to say public override void exit, and we're going to say public override void tick. This is where we write the logic for this state, and this is what's going to get passed back into the blueprint state script. And then we're going to want to make sure we use that keyword override, because that's what's going to allow us to override the virtual methods in our state script. This is going to be the base logic for all of our individual states. So for every behavior you'd like to make a state for, you're going to want to make sure you're setting it up like this. And then within that state, like if it's an attack state or a projectile throwing state, in tick you can write, instantiate a prefab that will fire a projectile, or whatever you want. Whatever the state is, you're going to write it in enter, tick, and exit. But this is the baseline for how we're going to write all of our individual states. And then when we want to change state, all we have to do is we're going to write underscore StateMachine, or whatever you made the name of that protected variable at the top. And then we're going to say dot change state. This is a reference to the change state method we wrote in the StateMachine script. And then we're going to write the name of the script for the state we want to change to in the brackets, and then parentheses and semicolon. And then all you have to do to apply this code to your boss in Unity is to take the StateMachine script and drag and drop it onto your enemy object, as well as all of the state scripts that you have written for the StateMachine, excluding the blueprint state script. Like the base one we leave, but every other individual state you made, you're going to want to drag on as well. And that's it for making a state machine. I would like to let you know that this isn't the only way to make a state machine. There are other popular ways. I know one of them involves using enums to make a state machine. So if this one doesn't work for you, there are other methods. But this is the one I like to use for enemy AI, or just general enemy behavior. But thank you for watching, and if you have any questions, please let me know in the comments down below.